I'm reviewing section 4.3 where we learned about side, angle, side and how to justify with flowcharts. We also reviewed angle, angle and side, side, side. In general, we're talking about how to show similarity in triangles. First thing we started with was side, 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 then angle, angle, and then side, angle, side. So side, side, side stands for sides are proportionate. So if you have two triangles, you can see that the sides are proportionate. This one's twice as big, this one's also twice as big, and lastly, this one is twice as big. And you need to show this with all three sides, that you have the same proportion of two. Side, side, side. Next, we went through angle, angle. So angle, angle means that you have two pairs of congruent angles. Here's a pair of congruent angles. Here's another pair of congruent angles. You just need to show that two of them are congruent. That is angle, angle similarity. Another way to show similar triangles. The newest one is side, angle, side. And to do side, angle, side, to show it, first you need to show a set of proportionate sides. Any set of proportionate sides. So here's one, it's twice as big. And then after it, in a row, you got to show a pair of congruent angles. These two angles are congruent. And then following that, it needs to be another set of proportionate sides. So side, then the angle, then that last side. And again, those sides need to have the same proportion. And have the same proportion of two there, or any same proportion. So we're going to justify similarity with a flowchart. We're going to look at this example below, and we are just justifying similarity. We're using angle, angle, side, 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 or side, angle, side. So I'm just going to write these three options here, just to know that we have them. We have these three tools we can potentially use. All right, let's get started on this example. So in this example, we've got these two triangles, and we want to figure out, is triangle XYZ similar to triangle whatever the other triangle is, but let's figure out how to name it. So how can we name this triangle? So we got to name it similar to how we named the other one. So which is in the same position as the X, which is corresponding? That's going to be B. See how they're both 60 degrees? That's how I know those are corresponding. So first I'm going to write B right here. So X goes with B. Which one goes with Y? So here's Y, 84, and A is going to be the same. It's corresponding. So BA, and then last Z goes with Z. So BAC. So is triangle XYZ similar to triangle BAC? Is this one similar to this one? And we are going to try to justify this. So first things first, looking at this, we need to fill these in. First it says angle Y is equal. Well, that should be congruent. Let's change that to say congruent. So angle Y is congruent to angle A. Let's just show those on the picture. So angle Y is congruent to angle A. Okay, cool. We know that. They're both 84. What about the other one? So we've got angle X. Angle X is congruent, add a little squiggle here. Angle X is congruent to angle, this is 60, this is 60. Okay, so angle B. So we're just going to write B, angle B. So angle X is congruent to angle B. All right, so we've filled in these boxes so far. Now we need to put these together. So we've got an angle congruence pair, another congruent angle pair. So all together, this is an angle and an angle. So all together, we're going to put this together to justify. We're going to use angle, angle similarity because we have two angles. We just showed two pairs of congruent angles. So we need to fill this in down here. So by angle, angle, just write that there, angle, angle similarity. I also need to name this triangle. So triangle XYZ is similar to triangle, and we'll just rewrite it as BAC, like we did before. And that's the end of this flowchart. Let's see another example. All right, so this example, I've got this nice bow tie picture, but it is two triangles. And we're going to try to figure out if these two triangles are similar. So are they similar? And we're going to be trying to justify and show this with a flowchart. All right, so this one's partially filled in. We're just going to fill in the rest of it. So right here it says JK over MK. Well, what does that mean in the picture? Let's take a look. So JK versus MK. And it's comparing the side lengths here. So let's write it. So JK 30 over MK 15. And we can reduce that. We can write it as 2. 30 over 15 is 2. Okay, so we've got that proportion. All right, so I'm just going to write up here, you know, we just compared some sides, the proportions. We got a proportion of 2. We're trying to look for a proportion of 2 later on, but we'll come back to that. This second box here, it looks like it's comparing some angles, showing that they are congruent. We just need to fill this in and write it in correctly. So angle NKM, start at N, go to K, then go to M. That gives us this angle right here. And we want to get the same angle on the other side. So what does N go with? N goes with L. That is corresponding to L. So I'm going to write L. See how they're both on that blue line? They're in the same position, so they're corresponding. So we go L, NKM is congruent to LKJ. You want to make sure you're writing this in the correct order. So angle all right, last order of business is this last box. And for this one, we are going to compare the sides again. We're comparing different sides this time. We want to see if we can get that same proportion. So before we did JK and MK, the green ones, now we're going to do these blue ones, LK and NK. And we started with the bigger number first on the top of the fraction. Last time we're going to do the same thing here. So LK over NK. LK is 50, NK is 25. I'm just going to color code this here to really show where it comes from. And, you know, in general here, I've got this last box I need to fill in. I need to write out the new triangle. So triangle LKJ, start at L, hit K, then go to J. We're going to label the other triangle similar, and we need to have the corresponding angle. So start with N, then K, then M. So triangle N, K, M. And how can we justify this? Well, we have a side, an angle, and a side. We just justified it with those. So side angle, side similarity is how we just showed that these two triangles are similar.